Uh, I, we talked the other day about lead poisoning swans, and there's an article that came out yesterday in High Country News on lead use of lead ammunition. It's focused on rifle bullets, uh, but it might be interesting for a lot of this audience. Um, and I mean, I like it because I'm quoted in it, but it's also a good article beyond that, I think. Um, and so the title I've got here is not the same title as in the in the program, and that's actually my fault. I should have changed it on here. And I am going to talk about the origins of these hunted swans. Before I get into it, I do want to thank, I don't want to forget to thank many of you in the room because I'm the guy who many of you have been sending feathers to. And I really appreciate all of your efforts to collect those feathers. And hopefully this will show you some of the results from that. What I'm going to show you is preliminary. I presented this stuff in March, I think at a GYE Trumpeter Swan meeting. And if you saw that, this is going to essentially repeat what I did there. We have a graduate student who is going to be digging into this, which is really cool because she's going to be able to do more than I would have been able to do. But we should get some more advanced results after this hunting season and into the coming summer. So we know, and Sharon talked about this a little bit, some parts of the Rocky Mountain population of swans are doing pretty well. There's somewhere more than 11,000 of these individuals. The vast majority of them are in the Canadian breeding segment of the Rocky Mountain population. The US breeding segment is small. The recovery has been slow, and there have been some concerns about the impact of hunting. We know, or at least think, that the population size is stable or slightly increasing, but we also know that hunting opportunities for swans have expanded. So there's a growing tundra swan season that is being implemented in a number of range states and winter range states. So this creates a bit of a management problem because there's an interest in preserving the small US segment of this Rocky Mountain population, but there's also an interest in allowing this take of tundras. And so the way that they've solved that, at least today, is they essentially shut down the tundra season once a certain threshold of trumpeters has been met. So, this is very precautionary, again, focused on the US population. But for example, in Utah in 2019, there's a take limit of 20 trumpeters allowed, right? And these are not, in theory, these are not trumpeters that are intentionally targeted. They're mistakenly taken when people are hunting tundras. But that threshold of 20 was met, and the season closed 2 days early. In 2020, that threshold was met, and the season closed 16 days early. And you can imagine that upsets the hunting population, but it's also not really the best way to manage and either of these populations, the tundras or the trumpeters. So there's an interest in addressing this problem. And the solution to this is to gain some understanding about the origins and movements of wintering swans. And if we can do that, we can, again, improve the management for both species. We can change hunting regulations to reflect that. And we can gain a better understanding of essentially both swan ecology and swan restoration efforts. So that's what this project is really focused on, studying movements and demography of these swans. There's a telemetry component that Sharon, Andrea, and Cody, and Bill, and others have talked about recently. And then there's also a component focused on passive geolocation to identify the origin of wintering and hunted swans. And by passive geolocation, I mean we're using stable hydrogen isotopes to understand where feathers were grown. And then we can take these data, and we can take these data and essentially propose a framework where we can understand how management and movement interact to influence population trajectories. So we've done some of this recently with birds that are taken at renewable energy facilities, right? And that's essentially the concept is the same. We can extend that to swans that are taken during the hunting season as well. And what we can do is we can look at the origins of these animals that have died for one reason or another. And we can say, okay, these X animals are from this subsection of the population or this subpopulation. And we can build a population model just for that affected subpopulation. And then we can do it again for the larger population. So in theory, we can build a population model for the Rocky Mountain, the US segment of the Rocky Mountain population and the Canadian segment of the population. And we can then use that to inform thresholds for take and things like that. So all of this relies on use of stable hydrogen isotopes. And I want to give you a really brief background on this. And if you have hard questions, you're frankly not really allowed to ask because I can't answer them because I'm not an isotope ecologist. But I know some of the very basics about this, and I have colleagues who are actually really good at it. And they have trained me over the years. But the basic principle is that when you have rainfall across North America, and North America is a little bit better for this than Eurasia, although we're doing some of this in Eurasia as well. Rainfall doesn't, there is hydrogen in the water in rainfall, right? And that hydrogen is predominantly just normal H2O, and the normal H is hydrogen that has a proton and an electron, right? But some of that hydrogen is heavy, it's deuterium, right? And you probably think back to like high school chemistry and stuff like that. Deuterium has a proton, an electron, and a neutron, right? And so it's just a little bit heavier. And there's a fairly constant ratio between the slightly heavier hydrogen and the slightly lighter hydrogen in water. And if you look at North America, you get slightly lighter water up to the north and I believe to the west, and you get heavier water to the south and the east. And that's really nice because when a swan or any bird grows a feather, the hydrogen in their feathers reflects the isotope ratio in that rainfall, right? Now, that's really cool. And it sounds perfect, except it's not perfect because there's nuance to it, which is also, I guess, what you'd expect. But the correspondence between what's in the feather and what's in the rainfall isn't perfect. It's not one-to-one, and it's kind of species specific, right? So one of the things you've got to do is figure out the relationship between the hydrogen in the feathers and hydrogen in the water. And to do that, the way we do it is we get known origin samples. You might get known origin samples from 20 or 30 different places that span this color gradient. And then you can begin to predict if I have a feather with this ratio, then it translates into something that looks like this kind of rainfall. And then you can predict where it would be on a map, right? So you take a known origin sample, and then you look at an unknown, and you develop a relationship, and then you take an unknown origin sample, and you use that information from the known origin sample to predict where that unknown origin sample came from. That translation from feather to precipitation, we use something that we call a transfer function. It's basically a regression, right? That transfer function really matters. And I'm going to show you that later today, or well, in a couple of slides. But that's also getting that transfer function right is really important because that's how we identify where these animals are from. So that's the basic background. We have gotten from people in this room and others 3,500 feathers from swans. We've got them sorted into 543 envelopes. We've got more swans coming in this hunt, or more feathers coming in this hunting season. And if any of you are involved in hunting efforts in your states and you can get more of these feathers, that's spectacular. We will process every feather, feathers from every bird that gets hunted. We may not be able to process feathers from other birds that die of other causes or they're live captured. But these 3,596 feathers were birds that were hunted, poached, collided with power lines, naturally shed feathers, lead poisoned birds, and some that were trapped. 60 of them were hunted. We've got birds from Idaho, Montana, Utah, and Nevada, kind of spanning the range. We've done analysis on 99 individuals, of which 24 were hunted. And I'll talk about those 24 today. And those analyses also span some of these states, the same states that we're talking about. So geographically, we've got which one's the pointer on this thing? The side or the top one? Okay, that's why it's hard. That's why people keep. Okay, so we've got the feather samples from really all throughout the U.S. segment of the Rocky Mountain population. We just got a few samples that were molted from up in Alaska, and those give us a really nice comparison, and they're going to help us understand a lot better where some of these feathers are growing. So we've got pretty good coverage. We've sent, as I said, about almost 1,000 of them to University of Maryland, where the isotope lab is, and we've analyzed 143 feathers from, as I said, 99 individuals. 57 of them are adults, and again, spanning a good bit of these states. So we take these feathers, we run the isotope analysis, and then we build a predictive model to understand where these swans are coming from. We've clipped this to the range of the Rocky Mountain population, or the purported range of the Rocky Mountain population, right? And there was a comment yesterday or the day before, somebody said that there was an Alaska bird that had been resighted at Seedskinny in Wyoming, and Alaska is outside of this distribution, and Seedskinny is obviously a bit outside of the distribution. So we're going to work with some banding returns to get some more information on this stuff. This is a bird that was taken in Idaho. All right. The red and yellow area is the area of highest probability of origin. When I say that, I don't mean that's where it was hatched, that's where it had its breeding season. I mean, that's where it grew its feathers. And that's also an important nuance that we're going to want to come back to. But as you can see, there's not a lot of red and yellow down in the U.S. segment or the range in the U.S. segment. And there's a lot way up north in Canada. So we're fairly confident that this bird grew its feathers way up north in Canada. I mentioned that transfer function. I said that's kind of important, okay? We used here a transfer function from a lesser scoff. There isn't one in the literature for trumpeter swans, right? But we recognize that lesser scoffs they look different, they act different, they eat different things. So a lesser scoff transfer function might not be that useful. In fact, when you use a mallard transfer function, you get a bird that still looks like it grew its feathers in Canada, but it's a lot farther south in Canada, right? So nailing this transfer function is a really important part of what we're doing. I think with this bird, we're probably okay in either case. This is probably a bird that grew its feathers in the Canadian part of the population. This is one bird from Oregon, from Montana. Same thing. This is a bird that probably grew its feathers way up north. This is lesser scoff. The mallard would be farther south, but probably still fairly far north. Nevada, there were 3 birds taken. 2 of them look a lot like those Idaho and Montana birds. One of them probably grew its feathers in the U.S. segment of the Rocky Mountain population. All right. And again, this is with the lesser scoff transfer function, but I think you're going to get a similar message in this case with either of these transfer functions. And then with Utah, we analyzed 19 birds. I'm showing about 8 of them here, and you're kind of getting the same story. The majority of them are from the northern part of the distribution, and then there's a few that these guys might be from the U.S. segment of the population. So in conclusion, it appears that most of the swans that have been taken during the hunt are likely growing their feathers in the Canadian portion of the range. A small number of these birds may have been growing their feathers in the range of the U.S. population. However, some of this can be confusing in light of the movements of these swans. And you'll remember that Sharon just showed telemetry data where birds were spending one summer in the US and the next summer in Canada, right? And, these birds are not listening to us. They're not doing what we tell them to. They're not staying in one spot. They need to do a better job of this, frankly. But we need to also figure out what's going on a little bit better. Some of this, there's also a paper that came out recently about molt migration in some of the Midwest trumpeter swans. And so all of this nuance needs to be kind of factored in. I think that one of the things that's really going to help us, first of all, we need to figure out the sex of these birds. And I think we can do that. We have feather samples, and I think that's going to help the analysis that Sharon and others are doing, but it's also going to help the isotope analysis. There's also ways to age birds using collagen breakdown products. And they're not going to tell you whether it's 8 years old or 9 years old, but they're probably going to tell you this is a young bird versus an old bird. And that might provide a lot of information. We aren't going to be able to get that information for these birds, but we might be able to in the future. That might be a useful thing to think about. So next steps and questions. We need to resolve these issues with the transfer functions. And we are doing that. We're searching for museum specimens. We have, I think, 20 or 30 known origin individuals. And so if we only have 20 to 30 known origin individuals, we can build a basic transfer function and also get a really good idea whether these things should have a transfer function that looks more like a mallard or a scoff or something else. If you have known origin swans, unfortunately, Bill's swans are not good because they're fed grain that's grown in the Midwest. And so if you look at their hydrogen data, they look like they're from Iowa or something like that, and they're obviously not. But if you have known origin swan, you've got a cygnet that ended up in your freezer, or if you're going to be handling cygnets next year, we know where those guys grew their feathers. I've been talking with the folks in Iowa as well, because their birds don't do a lot of migration and they molt in the same spot every year. And so we can have a pretty good idea if they molt, we know they probably grew their feathers in roughly that same spot the prior year. So if you have those, please let us know. Need to run samples from the current year and from last year. We need to write this up for publication. We need to think about the demography. One of the things I'd really like to do is develop a pipeline for rapid collection. So we could have a hunting season going, and every time a trumpeter swan shows up, a couple of feathers get pulled, the samples get sent to Maryland, they run the analysis, then the data gets sent to the person who's making these maps and doing the interpretation. And we can say, you know what, that swan was a Canadian bird. You don't need to count it towards your threshold. And that might allow us to do some adaptive management. It would be pretty cool. So thank you very much for your time and all of your interest. I brought up 3 things and stuff I'd love to talk to people about. Well, 2 things and one other. If you have known origin feathers, that would be great. I'd love to do some work estimating the age of these guys. And if anybody has really good modern information on molt of swans, that would be really useful, because that's the other side of things that we need to figure out. And as Bill said, there's a lot of people here who know swans, and that might be really helpful. So my clock says I'm at 19 minutes. So thank you all.